Today we're starting our trig derivative section. The most important thing that I can tell you from this section is to memorize these trig functions. You will use them in Cal 1, you will use them in Cal 2. You need to memorize them. They will not be provided for you. Please learn them. They are printed in your notes, of course, that you see here. You'll also see them inside your Canvas course. Please learn these. I cannot stress that enough. So the first derivative that you come across is pi cosine of x. That's what I'm asking you to calculate. Well, pi is just a coefficient, like a regular number. So all you have to do is bring down that regular number, which would just be pi, and it's pi times the derivative of cosine. So the derivative of cosine is negative sine. Now that's times, so cleaning that up, you would get negative pi sine x. And that's how that one would look. Now you would treat pi just like any other coefficient. That's what you would get. Okay, let's try another one. The next one you have is cosine of x minus pi over 3 sine of x. Again, the pi over 3 is just a coefficient, a regular number. You could actually divide it out and put a decimal in there if you wanted to. When you're taking this derivative, you can take the derivative of the pieces. The derivative of cosine, on your trig sheet, the derivative of cosine is negative sine x. Okay, so this sine value here has a coefficient, so I'm just going to bring down the coefficient. And then you take the derivative of sine. Well, on your sheet, the derivative of sine is cosine x. So that's your derivative. Memorize your trig rules. Okay, let's try a couple more of these before we get to the complicated ones. This time I ask you for the derivative of tangent plus cotangent. Okay, on your sheet, the derivative of tangent is secant squared. On your sheet, the derivative of cotangent is negative cosecant squared. And that's what you get. One of the things I want to point out about your derivative sheet is, if you notice, the derivative of the cosine, the derivative of the cotangent, the derivative of the cosecant, all of the trig functions that start with c, their derivatives are negative. So the derivative of cosine is a negative, the derivative of cotangent is a negative value, and the derivative of cosecant is a negative value. So that might help you a little as you study these. Okay, looking at this next one. The first part is just your basic power rule from previous sections. So I bring down my 2, and this would give me 5 times 2. Decrease my 2 by 1. 2 minus 1 would give me x to the 1. Okay, cosecant's derivative is negative cosecant x cotangent x. Negative cosecant x cotangent x, and that's how that one would look. Now, let me flip over just a second. Let's look at this one next. What you'll notice about this particular problem is you have a secant of x, and you also have an x squared. Well, that's two separate functions being multiplied together. So we've talked about this before, of course. Here's function 1, and here's function 2. So what you're going to have to do with this one is use the product rule. So we have function 1, and then we're going to have d1, and function 2, and then we're going to have d2. Okay, so my first function is x squared. Its derivative is 2x. My second function is secant of x, and its derivative is secant x tangent x. Okay, again, how I got d2 was I looked I looked at my rules that I provided for you in the Canvas course. The derivative of secant is secant tangent. Please know those for your test. Okay, this is the product rule. And the product rule says you're going to have function 1 times the derivative of the second plus function 2 times the derivative of the first. I didn't leave myself enough room, so I'm going to scoot it over a little. Function 1 times the derivative of the second plus function 2 times the derivative of the first. Okay, so let's plug in the pieces. Function 1 times derivative of the second function 2 times derivative of the first. Now then, we have to clean this up a little. So when we clean it up, what I want to make sure that you do not do is do not multiply the x squared through by the angles. Secant of x and tangent of x can't be changed. That x squared is just out in front. So cleaning this up a little, I'm going to get x squared, secant of x, tangent of x. And over here I would get 2x secant of x. Now, that's a good answer. And in a regular calculus course in a traditional classroom, that would most certainly get you partial credit. But for this purpose, we want to go ahead and factor and get it in its simplest form. So what we're going to do with this green value is we're going to go ahead and find our common factor, our greatest common factor, and factor that out. So I notice they both have an x and they both have a secant. So I'm going to take an x secant x out of both. This is just factoring. Take out your common factor. If I take an x secant x out of this first one, that leaves me with x tangent x. And if I take an x secant x out of the second one, that leaves me with 2. And so that is my answer. Now you'll say, well, which one of these are you going to ask us? That's a good question. So sometimes I know I can't speak for the homework, but for my purposes, sometimes you'll see this as an answer choice, that green part where it's not factored, and sometimes you will see it factored. So what you're going to have to do is just simplify it as far as you can and look for the answer that matches. You will not see both of them. I won't trick you that way. You won't see both of them. You'll only see one of the choices.